module, from this chapter, Sum Application of Trigonometry, we are doing a sum based on angle of elevation. Let's read the sum, understand the sum first. It says the angle of elevation of the top of a building from the foot of a tower is 30 degree and the angle of elevation of the top of the tower from the foot of the building is 60 degree. If the tower is 30 meter high, find the height of the building. Now students, that's the sum. Now when you look at the sum itself, from the sum you understand there are two things required here. We require a tower and a building. So these are the two things which we require here, right? Easy. Let's see the very first statement. It says the angle of elevation of the top of a building, right, from the foot of the tower. So we have marked those two things. So when you read this, you understand there's an observer making an angle of elevation. From where? From the foot of the tower. So that means the observer is there at the foot of the tower. But the height of the observer is not given. That means he is considered as a point. And from here, he is looking at the top of the building. Right, so there's a line of sight here and making an angle of elevation. So here the ground itself is a horizontal line and the angle of elevation which is made is 30 degree. So wasn't that easy to draw? Very simple, right? Let's move ahead now. It says in the next statement, and the angle of elevation of the top of the tower from the foot of the building. So from where? From the foot of the building this time. An observer is observing the top of the tower. So when he's observing, again there is a line of sight. So again there is an angle of elevation and this time the angle of elevation is given as 60 degree. They say if the tower is 30 meter high, that means the height of the tower is given to us as 30 meter. They say find the height of the building. So height of the building is something which you are supposed to find, right? Simple. So you have understood this. Now this is what you're supposed to draw, but you're not going to draw a tower and a building. You're going to name this triangle like this, right? The figure like this, A, B, C and D. These are the points which you have taken and ultimately this is the figure which you draw. Wasn't that easy? So this is what you're supposed to draw. Now once you've drawn it, let's try and understand how to solve it. But before that we have to describe, right? Write the description. So we write here in this first AB. AB represents the height of the tower. Beautiful. And we know that AB is equal to 30 meter. Similarly, we have CD represents the height of the building and we don't have the length of CD. That is what you're supposed to find. There are two angles given to us. One angle is angle DBC which is given as 30 degree and the other angle is angle ACB given as 60 degree. So this is the information which we have and what are we supposed to find? We need to find the value of DC. Now student, understand, I have always said in this type of sum, search for the right angle triangle. We have here two right angle triangle. Now whenever you have sum based on two right angle triangles, always look for the common side. What's the common side there? BC. So that is the first thing which we somehow need to get. Okay, that's a major point. That's the most important point. Remember that. So let's consider one right angle triangle, that is triangle ABC. Let's look at that. In that right angle triangle, look at the acute angle which is known to us, that is angle ACB. Now for that acute angle, let's see what is given to us. We have the opposite side AB given to us and we need to find that adjacent side BC because I said we want that common side. So we are talking about a ratio which involves opposite side and adjacent side. So which ratio comes to your mind? Yes, it is tan. So we are going to use tan for that particular angle. So tan of 60 is equal to AB upon BC. So now we substitute the value of tan 60 from the trigonometric table. We know that it is nothing but it is root 3. So we write root 3 is equal to the value of AB. Do we know that? Yes, we know that is nothing but 30 and the value of BC we don't know. Keep it as it is. Right. So now we solve it. We take BC to the left hand side. Root 3 comes into the denominator. So now we have BC is equal to 30 upon root 3. You know what students, here in this fraction in the denominator we have any rational number. So we need to rationalize it. So we are going to rationalize it. So let's rationalize it by multiplying root 3 in the numerator and root 3 in the denominator. This is what we do. Now isn't that very easy further? Yes. So we solve it further. So in the numerator now we'll have 30 root 3 and in the denominator we have root 3 into root 3 which gives you 3. So now can we reduce it further? Yes. So we do the cancellation and we get BC is equal to 10 root 3. So students, I said we wanted that common side. Have we got that? Yes. Now this will help us to get the value of DC in the other right angle triangle. So now we consider the other right angle triangle now. So we write there in that right angle triangle DBC. So what we write in right angle triangle DBC? We write, observe that acute angle which is known to us, that is 30. So for that acute angle, which side we need to find? We need to find the opposite side DC. And what is known to us? We know the adjacent side, that is nothing but BC. So again we require a ratio which involves opposite side and adjacent side. So what's the ratio? It is tan again. So we're going to use tan of 30. So we write tan of 30 is equal to DC upon BC. Now substitute the value. The value of tan 30 from the trigonometric table we know is nothing but it is 1 upon root 3. So we substitute that value. And the value of DC we don't know. Keep it as it is. But what's the value of BC? It is 10 root 3. So we substitute that value. Now isn't that easy? Very simple, right? So keep DC on one side, 10 root 3 moves on to the other side. So we get DC is equal to 10 root 3 upon root 3. Root 3 and root 3 gets cancelled. And now we get DC is equal to 10. Now students, that is what you were supposed to find. That means now we can say that DC, which is nothing but the height of the building, is 10 meter. And that's the sum. Wasn't that easy? A very interesting sum, right?